Well, hello guys. On Friday, we talked about solving absolute value equations, and I gave you 8 problems to work. And so before I start the lesson, the part that we're going to add on to it today, I just want to make sure that you understood what we did on Friday and that you know what's going on. So this is the worksheet I gave you on Friday, and we're going to finish it today. And I assigned you to work numbers 1 through 7 as well as number 13. So we're just going to quickly work these. And what we discovered on Friday was that if the absolute value of x plus 3 was 5, then one of the answers was just what you get when you solve that equation, x plus 3 equals 5. The other equation comes from if you just take the opposite of what's inside the absolute value bars, because we know that not only is the absolute value of 5 equal to 5, the absolute value of negative 5 is also equal to 5, which is why we have to take into account the two cases. So if I take the opposite of everything in here, this x that's positive is now negative, this 3 that's positive is now negative, and it's equal to 5. Don't take the opposite of what it's equal to. That would be wrong. And now just solve both of these equations. If x plus 3 is 5, then you know you could subtract 3 from each side and figure out that the first answer is 2. Over here, you're just getting this x by itself. So you have negative x is equal to 8, and you've got to get rid of that negative. So here, x is negative 8. And just a quick check, you don't have to do this part, you don't have to write this part down, but you should just check it in your head and make sure. If x is 2, 2 plus 3 is 5. The absolute value of 5 is 5, so you know that that's correct. If x is negative 8, negative 8 plus 3 adds up to negative 5, and the absolute value of negative 5 is 5. So that's how you know you're doing them correctly. All right, so here, absolute value of y minus 6 is 4. So your first equation, y minus 6 is equal to 4. Your second one, you're taking the opposites of both of these. So negative y plus 6 is 4. And now I'm just solving both of these for y. First answer is 10. Second answer, 4 plus negative 6 is negative 2, and you still have to divide by negative 1, and you end up with y equals 2. I had a lot of people asking me about this problem on Friday because they felt like you should always have one positive and one negative answer. You don't have to. They can both be positive, they can both be negative, or it could be one of each. It just seems like most of the time it's one of each for some reason, but it's fine because if you check this, 10 minus 6 is 4. The absolute value of 4 makes 4. The other answer of 2 minus 6 is negative 4. Absolute value of negative 4 is 4. So this is also correct. One more quick thing that I want to address is some people got a little bit confused on Friday. When they came to the answer being a negative number, they decided it was no solution. Your answer for x can be a negative number. You can't have the absolute value equal a negative here. So if you had something like, I'm just going to jot this in here, the absolute value of x plus 2 equals negative 5, where you've got absolute value equaling a negative number, that's the type that's no solution. Your x value can have a negative answer. You can't have absolute value equal to a negative answer. All right, I know that's confusing. Number 3, negative 2w is equal to 8 is my first equation. Sorry, opposite, so positive 2w equals 8 is my second solution. This one seems really easy because all I have to do is divide by 2 or negative 2. This side, w is negative 4. This side, w is positive 4. Quick check, negative 2 times negative 4 is 8. Absolute value of 8 is 8. If w is positive 4, negative 2 times 4 is negative 8. Absolute value of negative 8 is 8. So those are good answers. Fractions always seem to bother you guys. First equation, x over 2 is 4. Second equation, the negative of that, so negative x over 2 equals 4. Don't change both of these to a negative, because if you did, the negative of x over negative 2, the two negatives would just cancel one another and you'd be right back to where you were. When you have a 2 on the bottom side, so the denominator, the way you get rid of it is you multiply by 2. Make sure you do that to both sides so that these will cancel. Here I have 8. Again, I'm multiplying. Here I have negative x equals 8, and when I divide by the negative 1, x is negative 8. 8 over 2 is 4. Absolute value of 4 is 4. Negative 8 over 2 is negative 4. Absolute value of negative 4 is 4. Two equations. 5x minus 5 is equal to 20. Opposite of both of these, so this 5x becomes negative, this minus 5 becomes positive, and I'm just solving both equations. So on the left-hand side here, I have it to 5x is equal to 25, which means x must be 5. Over here, I have negative 5x is equal to 15, which means x must be negative 3. Quick check. 5 times 5 is 25. 25 minus 5 is 20. Absolute value of 20 is 20. For the negative 3, 5 times negative 3 is negative 15. Negative 15 minus 5 is negative 20. Absolute value of negative 20 is 20. That's when they're trying to trick you because they wrote it backward, but if it bothers you, if 12 is equal to this, then this is equal to 12, and I can just pick this up and move it over here to this side. First equation, 4x minus 8 is 12. Second equation is just the negatives of these, so the 4x becomes negative, the 8 becomes positive. And now I'm solving both sides. And the good news about these is they're easy equations to solve. You're very comfortable solving two-step equations. These are easy compared to some of the things you've been doing. On this side, I end up with negative 1. And just a quick check, 4 times 5 is 20. 20 minus 8 is 12. Absolute value of 12 is 12. For the negative 1, 4 times negative 1 is negative 4. Negative 4 minus 8 is negative 12. Absolute value of negative 12 is 12. These answers are correct. Number 7, two equations. 2y plus 1 is 17. And the negative of what's inside there, so negative 2y minus 1 is 17. This side I have 2y is 16, which means y is 8. This side, negative 2y is 18, so I can solve this to get y is equal to negative 9. 2 times 8 is 16, 16 plus 1 is 17, absolute value of 17 is 17. For the negative 9, 2 times negative 9 is negative 18. Negative 18 plus 1 is negative 17. Absolute value of negative 17 is 17. All right, one more on the back, number 13. So again, two equations. First one, 5z plus 7 is equal to 7. The second one, the negative of this, so negative 5z minus 7 is 7. And this one confused a lot of people because when they solved this side for x, they did the minus, I'm sorry, not for x, for z. When you minus the 7 from each side, you end up with 5z is equal to 0 because those canceled. 0 is a number. A whole lot of people put no solution on this. That's wrong. 0 is just a number. It's not a number we like because it tends to make us make mistakes, but I can still get the z on one side all by itself. 0 divided by 5 is just 0. That's one of my answers, 0. Over here, when I add the 7, I get a negative 5z is equal to 14, which makes you guys think that you're wrong when you get ugly fractions and decimals like this, but if z is equal to 14 divided by negative 5, it's just negative 14/5. Don't like anything about that, but that's the answer. Quick check. If z is 0, 5 times 0 is 0. 0 plus 7 is 7. Absolute value of 7 is 7. This one, when you put the negative 14 over 5 in place of z, it's going to look like this. 5 times negative 14 over 5 plus 7. All that happens is these 5's cancel, so it turns into negative 14 plus 7, which is negative 7. The absolute value of negative 7 is 7, which means that this answer that you really just don't like to look at is correct. All right, that's what we did on Friday. Today we're going to add just a little bit to it. I'm switching to your notes from Friday where we left off that says we will do tomorrow. It's finally tomorrow, 3 days later. So the only thing that we're adding is on all of the problems that we solved Friday, the absolute value bars were already by themselves. And when I say that, I'm talking about on one side of the equal sign, there is nothing outside of the absolute value bars. So if you look at this example, my x that's inside the absolute value bars, this 2 is not in there. Before I can start solving, I have to get the absolute value part by itself. So you're looking to see what's happening to the absolute value and getting rid of it before you begin. So this 2 is multiplying the absolute value. The reason I know that is if it was adding, it would have a plus sign. If it was being subtracted, there'd be a minus sign. If it was dividing, it would be on the bottom. When there is no sign, that implies multiplication. So to get rid of this 2, if I divide both sides, this would be gone, and I would have the absolute value of x is equal to 5. Now I can solve both equations. These you don't even really have to think about. You guys all know that it's positive or negative 5. Okay, but here, my absolute value has something added to it. It has a 5 added to it. So before I can do anything, I need to get the absolute value isolated, is what they'll call this, isolating the absolute value. 7 minus 5 is 2. Now I can make my 2 equations and solve. Look at it and decide what it is. What value of x inside absolute value bars equals 2. And I hope you know that it's positive or negative 2. Okay, again, the absolute value bars have to be by themselves before you can start solving. So if this 4 is being subtracted, I need to start by adding the 4. And now my absolute value is isolated, and I can write my 2 equations. 2x equals 8, or the negative of this is equal to 8, which when you divide and solve, this side you have x is equal to 4. Here, x is equal to negative 4. And you can always do the quick check. It's a little bit harder, I guess, when you have to do this part, but 2 times 4 is 8. Absolute value of 8 is 8. 8 minus 4 makes 4. This would make negative 8 on the inside. Absolute value of negative 8 is 8. 8 minus 4 is 4. Back to your favorite part, the fractions. This absolute value is being divided by 3. So before I do anything, I need to get rid of that 3 that's down there by multiplying, so that this 3 will cancel this 3. So on this side, all I have is the absolute value of x. Over here, 2 times 3 is 6. And you guys know that this is just positive or negative 6. This one looks kind of tricky because you know that absolute values cannot be equal to a negative number. And right now the absolute value is equal to a negative number. But also, before you can even begin to solve an absolute value, the absolute value part has to be isolated. So this negative 3 that's multiplying it, you've got to divide both sides to get rid of the negative 3. So you can see what's going to happen is that the negatives will cancel, and you actually end up with the absolute value of x is equal to positive 3, which means x is plus or minus 3. Here, your absolute value has something added to it, so if you subtract it, you end up with the absolute value of x is equal to negative 2. And And I'm warning you that you'll just get on a roll working these, and it really, really feels like this should be equal to 2 or negative 2. But remember, absolute value cannot equal a negative number, so it's no solution. You can write out no solution if you prefer. The reason it can't be 2 or negative 2 is if you take the absolute value of 2, it's 2, not negative 2. If you take the absolute value of negative 2, it's 2, not negative 2. There is no number you can take the absolute value of and get a negative answer. All right, here, your absolute value bars are being multiplied by this 2, so before you can do anything to start solving it, you got to get rid of that 2. This leaves you with the absolute value of x plus 3 is equal to 5. Now you can do your two equations. X plus 3 is 5, and the negative of both of these, negative x minus 3, is 5. And solve. So here you have 2. Over here, you have negative x is equal to 8, and when you divide, x is equal to negative 8. And again, a quick check to show that it's true. Here, your absolute value has a plus 7, so you're going to minus 7. So you have this. Absolute value of 2x is equal to negative 2. And then I hope you see that since absolute value is equal to a negative, you can't solve that one. And finally, this one has more than one thing happening to the absolute value. It's got this 2 multiplying it and this 3 being subtracted. So just like when you solve an equation, you get rid of anything that's added or subtracted first, that's what we're doing to get this absolute value by itself. So the first thing we have to move is the minus 3, and we're going to do that by adding 3. So these will cancel. I still have this 2 out here with my absolute value of x plus 1 is equal to 8. And now I'm getting rid of the 2. So now I have the absolute value of x plus 1 is equal to 4. Now you're ready to get your two answers. X plus 1 is 4. And your second equation, the negative of this, negative x minus 1, is 4. And just solve. There's x equals 3. This side, negative x is equal to 5, so x must be negative 5. All right, one more thing to talk about. It's kind of confusing when you see these word problems, but keeping in mind that absolute value is the distance that something is from 0. So when I ask you to write and solve an absolute value equation that represents the two numbers x that are 5 units from 3 on the number line, I know that's confusing. The x is going to be something that's inside the absolute value bars. Since we want to know when it's 5 units away from something, the units away from something is what it's equal to. It's equal to 5. So we want to know the absolute value of x minus 3 equals 5. That's the hard part. Solving it's easy. If x minus 3 is 5, then I can solve and get x equals 8. If the negative of this were true, negative x plus 3 is 5, and you solve it, you would end up with negative x equals 2, which means x is negative 2. Now, the question is, they wanted us to find two numbers that were 5 units away from 3 on the number line. So if you think about this number line, and you've got it going all the way up to 8, so and then my negatives on this side. It makes more sense if you can see it in this way. They want 2 units that are 5 away from 3. Here's 3 right here. 5 away would be 1, 2, 3, 4, 5, which is this one. 5 away in this direction, 1, 2, 3, 4, 5 would be this one. To me, it makes a lot more sense when you can see it this way. So here, if you're going to write and solve an absolute value equation that represents the two numbers that are 6 away from -2, then really what you're going to do is the 6 is what goes on the inside like this, and it's going to be away from -2. I just said that backward. I'm sorry. These are confusing. 6 units away from -2. So if I go to the -2 on the number line right here, and I go 6 units away, so 1, 2, 3, 4, 5, 6, looks like your first answer is going to be this. You'd have to extend your number line out this way to get the other one, but you need to go ahead and write the equation because you are asked to write and solve the equation. So this just helps me get it in my head to how it looks. I know that the -2 is what's going to be in here, and it's going to be 6 units away from it, so it's going to equal 6. Now if it's a -2, I'm going to have to put a plus. Very confusing. If x plus 2 is 6, then my first answer is the 4 that we already knew, x equals 4. If I take the negative of both of these to get my answer for x, I'm at -x equals 8, which when you divide, x is -8. Well, that's really squished in there, but it makes sense. If x is -8, if you counted back 6 from -2, you would end up at -8. So this one's really squished. I know you can't see it very well, but your answers were x equaled 4. That's what you got from this one. And your second answer is x equals -8. All right. The worksheet that you did yesterday that we already talked about today, you need to finish all the ones that are not done. So numbers 8 through 12, and then on the back, 14, 15, and then 16 through 19. We also put an answer bank on the back so that you could cross out the answers as you get them and know that you're doing them correctly. So the ones that we already did, the 8 problems, you should probably go through and cancel those out first. Like on number 13, your answer was that 0 and -14 over 5. Go ahead and mark that answer out, and then go over on the front and get all these answers and mark them out. And then as you work each of these, flip over to the back and see, is that one of the answers that was given? Am I on the right track? Am I doing this correctly? You are turning this paper in. The lights just went out. You are turning this paper in before you leave, even if you don't finish, because I need to see what you have done in class today. I feel like you should have time to finish, and I'm going to look at these, grade them, and make sure that you have been on track doing what you're supposed to do. Please make sure you plug your computers in when you put them up and put them in the correct slots. Thank you.